Okay, let us start with video. Okay, now in this video we'll look at digital read and analog write. So we are reading a digital value. The input is digital, whereas the output expected is analog. So again we have a switch which will be giving 0 volt when it is open, that is when it is not pressed. Okay, let us take this as resistor R1 with 1 kilo ohm resistance. So if switch SW1 is open, so I will have, okay, let us take this as pin number, maybe you can just take whatever pin number. So let us take it as pin number 4, and let us see what should be these pin numbers of output, which is analog output. We'll see that, okay, once we just, okay, go there, go to Arduino and try to do a circuit. So now we know that when switch S1 is open, this is open. Now this is like directly connected to, it's connected to ground through a resistor. Since there is no current flowing, the voltage is pin number 4. Pin number 4 will be 0 volt. Suppose if switch 1 is closed, when I say closed, when it is pressed, we'll get this 5 volt coming to pin number 4. So this is 5 volt. So let us try to find out what is this. Okay, let us have a what requirement of, if switch is open, if the switch is open, let the voltage be 1.2 volt. And of course, when it is open, let this be 1.2, let this be 0 volt. So when the switch is open, so when the switch 1 is closed, let us have it as 0 volt, let us have it as 3.6 volts. So this is a requirement. When it is open, this should be 1.2, this should be 0 volt. When it is closed, when the switch is closed, this should be 0, this should be 3.6. Now let us see, okay, how do we get this analog voltage of 1.2 on this as 3.6. Now we know that this is a microcontroller. We all know that microcontroller, okay, I hope, okay, there's no disturbance. So this is this has a inbuilt uh, digital to analog converter. So this has got a 8-bit digital to analog converter. So when I say 8-bit, the analog, okay, this is digital to, okay, input is 8-bit, and you're going to have an analog output voltage which is a single bit. So this is something like this. So you have 8 bits of, okay, now this is 8-bit input, and this is a single bit analog output. So this is analog output, this is 0 1 2 3 4 5 6 7. So this is DAC. So this will have a V reference voltage, which is 5 volt in this case, 5 volt in this case. Now this is a single line, so I'll say it as single line. Let me not say it as single bit. So the output voltage can vary from 0 to a maximum of VFSV. So full scale voltage. Now this voltage can go from almost 0 to approximately 5 volt. So now we know that it is 0 to 7, totally 8 bits. So totally 8 bits are there. So you can have this inputs as B0, B1, B2, B3, B4, B5, B6, B7, B8. So these are the 8 inputs you can, sorry, B7 only, including 0, B7. Suppose if it is something like, okay, 1 0 1 0 1 1 0 0. If this is the input for this DAC, so this is the binary input. So what is the decimal equivalent of this? We know that decimal equivalent of this is position, this is, okay, 8 4 2 1 16, this is 32 64 128 is the weight of each of the bits. So since we know that this is now 1, this is, okay, totally 5 plus 16 is 20, 121 plus 32 is 21 plus 32 is, so we have it as 53. So the decimal equivalent of this binary number is 53. So we know that when all the bits are 0 0 0, you have 0 volt. When all the bits are 1, it's approximately 5 volt. So when only one bit is 1, when only one bit is 1, if all rest of the bits are 0, when I say one bit means this is LSB, least significant bit, this is most significant bit. If the least significant bit is 1, the output voltage you'll get, suppose if I say this as V0, V0 is equal to so it is 1 LSB multiplied by, so what is this number you have? So 1 LSB into the decimal equivalent is decimal equivalent. So now is it not, what is this 1 LSB? 1 LSB is V reference divided by 2 power n, where this n is the number of bits, and of course into decimal equivalent of that number. So now what is this? It is 5 by 2 by 8 into 53. So this is what the number you have. So what is this now? 5 divided by this is, let me write it as, okay, 5 divided by 2 power 8 into 53 is equal to 1.035 volts. So if we have these as the input bits, we will get 1.035 volts. So let us take, okay, instead of taking it as some voltage which is 1.2, let us take it as 1.035 volts only. So let us take one more example where it is something like this. So let me make this 1 0, maybe 0 1 0 1 0 0. Now what is this now? So this decimal equivalent of this is actually a decimal equivalent, or the decimal equivalent of this is 128 16. So what you have, of course you can able to convert this, can feed this to binary number. Let me just do it quickly now. 128 plus 16 plus 4, so this happens to be 148 decimal. So let me just come here, in place of this 53 let me put 148. If I put 148 and then find out, is it not 148 into 5 divided by 256? Now you're getting 2 point, so let us make this 2.89 volt. The voltage that you'll get there is 2.89 volts. So now when it is red, okay, when the switch is open I should get 1.035 volts. When the switch is closed I should get 2.89 volts. So let us not have this, let us have these two voltages. So decimal value that you should feed into this or the binary equivalent binary number as this, its decimal equivalent is 53. So let us feed 53 and 148 and see what are the voltages. So now let us see which pin we should connect it here. So let me just again go to create, it's a circuit. So I'm creating the circuit. So let us take the dummy circuit now. Let me take this Arduino. Now if you can carefully see this, let me just show you. Can you see these are all, actually these are all digital IOs. You can see digital, there is a PWM also given. So whichever is assigned with this symbol, it's a PWM output, which is nothing but analog output. So this is analog output, this is also analog output. Okay, out of how much? This is out of 2 to 13. So you have actually 14 digital IOs, out of which 6 are analog outputs. So let me assign it to either pin number 3 and 5. So let me just make it as 3 and 5. This is 3 and 5. 4 is the digital input. So let me go back to this. Let me close this. Okay, let me rig up this circuit now. So now I will, okay, what is that is required? Let us go one to one. This is circuit what I want. So I need to have a resistor and I need a switch. So let me take a push button switch, maybe here. Let me just put this down and I should, okay, this is voltages. So let me put some voltmeter to measure the voltages. Okay, I have multimeter. So let me have one multimeter. Okay, let me name it as V1 and let me have one more multimeter which is V2. Let me name it as V2. So there are two voltmeters, one is V1, V2. Let me connect it. So I have two multimeters, one is here, other is here. If you can see now, this is connected to, okay, one is, let me connect this, okay, let me keep this here. Let me connect this 1A to VCC. Where is VCC? VCC is 5 volts here. This is 5 volt. Let us change this color to red. And other end of the switch will go to, that is, if it is this number, this is 2A, this was 1A. Let me connect this to a resistor. Okay, this is connected to resistor and this resistor end is going to ground. So I have a ground. So let me replace this by black color. Let me have this intermediate by some other different color. Let me have it as yellow, which is like input. Now this should go to pin number 4. Okay, where is this pin number 4? This is pin number 4. Will actually go to this. Okay, connected this. This is actually pin number 4. Okay, this is the input. That's what is here. So let us connect. Let us see the output. Okay, this is ground here. Oh, sorry, this should be grounded. Let me connect it to black. And this is again ground. Let me connect it here. This is also ground. Let me connect the same thing here. Let me just make it slightly better visibility. Okay, looks nice now. Maybe you can just make this also slightly different. Now this is, since it is V1, it is connected to 3. This is connected to 3 now. So let us make this output as blue. And we have one more input, V2, which is 5, which is pin number 5. Okay, now we have connected this entire thing. So there is a resistor. Okay, let me just see the resistance. It's already 1K, fine. Now we have this connection made. Now we need to write the code. So what does the code says? If the switch red value is what is open, when it is open means you'll get 0 volt. When it is 0 volt, you should be assigning V naught here. Okay, let us write this. So let me write the code now. This is code. Let me take the text. Now you have this, and we just define something. So constant is okay. Let me just use switch 1 is what? It's an integer constant int switch 1. We have assigned it to pin number 4. Pin number 4. And then let us define one more integer which is a constant. Let us name it as v1. That was assigned to 3. And there is one more constant which is an integer. It is v2. It is 5. So these are all the pins that we have set. Let us also define some variable vol value or val Okay, I can define it as some value, or okay, this is may not be required, so let us just, so this is output, I have it as, let me just copy paste three things. So one is SW1, let us replace this one. SW1, SW1 is what? Input. It is input, and we have outputs as V1 and V2. It is V1 is output, V2 is also output. Now we will write a condition if read the value, that is digital read of which one? SW1. If it is high, what to do? So you have to do, you have to assign uh, analog analog write, what you have to write? You have to write, what is that? V1, V1 by what? Okay, when it is high, what you want? You can see here, when it is high, so when it is high, I want okay, when it will be high, so that is when I press it, it will be high. So this should be switch 1 is closed, V1 should be 0, whereas this should be 2.89, 2.89 148. So shall I make this V1 as 0, and I should write, okay, this is semicolon required, and write off analog write off V2 should be 148, is it? Sorry, V2 should be, this should be 148. That is, if the switch one value, if the value that is read, if it is 5, so as per this what happens, when the switch is not closed, it will be reading 0. When the switch is closed, we'll get 5 volt. When it is 5, as per our requirement, the switch is closed, V1 should be 0. So that's what I have here. So maybe you can see here. So when the switch is high, when the switch value read is high, I should get, so this V1 should be 0. So V1 is 0 here. Where is V1? V1 is 0, whereas V2 is, so let us make them as capital here also. Capital V1, this is V2. We have assigned this. Else what should happen? Else means if the value is low, if it is not pressed, you should get this as 1.05, that is 53. Otherwise it should be, let me just copy this entire thing, copy this and then paste it here. Let me take out all these things which is not required now. Okay, let me just take this out. Okay, what should be V1? V1 should be 53 as per this. 53, this should be 0. This should be 0. Now this will certainly give you the voltages. Let us also define one more thing. Serial dot begin data rate baud rate 9600, and you write, now what you're writing, okay, let me write what is that? Serial not print ln, what value that you are supposed to print. So I want to print it as 148. 148. That means that, okay, when it is high, the value is 148 will be displayed. That will be displayed up till a delay of 1 second or 1000 millisecond. So let me just make it as, okay, 1 second may be too much. Let us make it as for every 100 millisecond. Let me do the same thing to display 53, to display, let me get 53 here. 53. So what will happen is, when I press it, I'll get 5 volt. I'll get 5 volt here. When I get 5 volt, I should get what is that? This should be one. Okay, at this point it should be getting, at V2 you should be getting 2.89 and other voltage should be 0. When I don't press it, it should be 1.025 volts and the other one should be 0. So let me run it now. Now it is running. Let us see what happens now. So let me also see the serial monitor. Now I can see, since I not pressed it, we can see when it is open. Okay, let me just change this. Instead of 0, what you should get? You should get, okay, when it is open, V1 should be, this should be displaying 53 and this should be displaying, okay, 128, sorry, 148. See now, is it actually open now? When it is open, let me just show you now. I have not pressed it, so I have not pressed anything. So as per our requirement, if it is open, this is actually V1 V2, this is V1, this is V2. See here, is this V1 V2? So this is when the switch is open. Okay, let me, when the switch is open now, you are supposed to get 1.035 volts. That's what you're getting, and this should be 0. This is actually V1 and V2. If I press it, then this will become 0, this will become 2.89. See now, can you see it is 2.89, this is 0 when I pressed it. When I release it, if I don't press it, then this will become 1.035, this will become 0. So okay, you can see the same thing in your serial monitor. In your serial monitor, if you can see here, suppose if I press it, it will become 148. See that? Can you see that 148 coming? This is 148 being displayed. If I release, it's 53. It's 53. So that's what it says. So when you're, of course, okay, let me just take out this area because of this delay. It is okay. Let me just stop the simulation and then delete this. I'll delete this entire thing. Now it will become faster. Can you see it is keep coming faster? If I close this, can you see 148? If I release it, 53. If I press it, it is 148. If I release, 53. So this way, what we are trying to do here is, we want to read the value through switch SW1, which is red here. If it is high, I'm assigning 0 to V1. I'm assigning 0 to 1 if it is high. That is, when I press it, it will be high. This is V1, this is V2. This V1 will become 0 and V2 will become 128. Can you see now? If I press it, is it not becoming 0 volt? And this 128 is nothing but 2.89 volts. So 2.89 volts. If I release it, it is 1.035 volts. This is 0. So that's how you can able to see this. Okay, let me see, can we able to see the waveform of this or not? How do I see that? Okay, let me just see. Do I have a scope here? There's an oscilloscope also available. I'll take this oscilloscope and try to show you how does the waveform will look like when it is 2.89 or so. So let me simultaneously show you the waveform of this as well as this one. So this is now positive. I will connect this to this, and then I will short the ground and ground of these two, and I will short it to this my ground. Okay, I will short this to okay, this is my ground. Okay, all these are ground points. Let me change it to black. Change this also to black. Okay, this is blue, fine. This should also go to this. Okay, this is also fine. Let me change this also to, let me connect from here to here. Let me change this to blue. So this is now the waveform corresponding to V1, this is corresponding to V2. So let us run it now. If you can actually see this waveform, what I'll do is let me just make this time per division bit, let me stop this and make it as maybe 1 millisecond per division. Start this. Can you see now? This is a waveform that you're getting for 1.03 volt. See, if I press it, we know that okay, 0 means it is 0. If I press it, this becomes 0. Can you see the shape of the waveform that you want to get there? Okay, let me change this. Okay, here. So what I'll do is I will stop this and change this also to 1 millisecond. And let me run this. Now when I run it, this is fine. When I press it, see the difference? Now can you see this? When I press it, this becomes 0. Okay, see now when I press it, see the difference between this. Can you see this is a different waveform and this was a different waveform? Now let me make it, instead of 148, let us make it some 220 or 230. Let us see how it comes. So what I'll do this, I'll stop it. I will go to code. Instead of 148, let us make this some 220. 220. Let this also be 220. So what is this 220 corresponds to? So this 220 actually corresponds to, see now it is 220, okay, 220 into 5 divided by 256 is actually 4.29 volts. If I run it, when I press it, it should be 4.29 volts. See now, is it not 4.29? If you carefully observe this, let me again stop this and then show you the difference. Let us make it 0.02. Okay, 0.2. Let me send it now. Just see the difference now. Let us make this also same thing. Let me make this also 0.2 or maybe 0.4 would be fine, so that you can see both of them here. Let us make this also 0.4. See, this is the pulse width. If I just do this, I just press this. Can you see this? A different waveform. Can you see the duty cycle of the thing when it is, this duty cycle is more compared to this duty cycle? Can you see this is a duty cycle? If I press it, can you see duty cycle is different? Duty cycle is different. What I mean to say is, let us come to, because you might have seen that this was written as PWM. Can you see this was written as PWM? This is PWM. So this is PWM. So whenever you want to take the output voltage, you need to either connect it to 3, 5, 6, 9, 10, 11. You cannot get the digit analog output from anything other than these 6 pins. If you want to get analog output, you have to use these PWM pins. Let us see what is this PWM is. Now you might have seen that let me show you here the type of waveform you got it for 1.02 volt and 4.29 volt. For 1.02 volt was the waveform something like this, whereas for 4.29 volts was the waveform something like this. You can see here T on, this is total T, this is now T on, this is total T. So duty cycle is given by T on by T. Here duty cycle is T on by T. So if this duty cycle is assume that it is 1 millisecond. If it is I don't know, okay, what is the exact time, can we actually measure that duty cycle or the total time? Can I just go back here and then can I measure it approximately? Let me just see. Okay, do I have this as 1 division, 2 division, 3 division, 4, 5 divisions? 5 division into how much is this? How much is this? It is 0.4. Can you see now? So T is equal to 5 division into, okay, 0.4 millisecond per division. Is it not 2 millisecond? So it is now 2 millisecond. So you have the total time as 2 millisecond, and okay, this is hardly 0.5. So what is duty cycle for this one now? This is what I had. This is actually 0.4, as from here to here it is 2 millisecond. This is what I have. See, this was actually 0.4 millisecond, 0.1 division. This was actually 5 divisions. So total T is 2 millisecond, whereas on time is 0.4 millisecond. Can I find what is the duty cycle? So duty cycle is T on by T. Is it not 0.4 by 2 millisecond? So 0.4 by 2 is 0.4 divided by 2 is 20%. So you have duty cycle 20%. So when the duty cycle is 20%, average voltage V average is 5 volts into 20%. So what is 5 volt? Okay, 20% of 5 is 5 into 0.2 is 1 volt. That's why you had almost close to 1 volt, which we expected as 1.02 volt. Next, when this is pressed, when it is pressed, can you just go back and see when I press it, what is the duty cycle? Okay, I cannot exactly measure, but that time, is it again still how many cycles you have? So can you see the on time is more now? On time is actually more than the off time. So now if you have the output voltage, this is V out is equal to VCC multiplied by reference, that is 5 volt. Sorry, V output is VCC multiplied by duty cycle. So how much you have it as? 4.29 is equal to 5 into duty cycle. Then what will be duty cycle? Is it not 4.29 by 5? It's almost 85%. 85.8% is the duty cycle. That is, the on time is more, off time is less. So that's why you can see here when I press it, can you see the duty cycle of this waveform is more? This is more here. This on time is more, off time is less. So duty cycle is almost close to 85%. Suppose if you want to get 50% duty cycle, then this value should be 128. So I'll just go back here. I'll make it 128. If I just type it as 128, I'll be getting 2.5 volts. So run it now. When I actually close it, you can see, are you not getting 2.5 volts? Can you see, is it not 2.5, close to 2.5? Can you see duty cycle of this is 50%? So that is here, if you want to get this as 5 volt, then if you want to get this as 2.5 volt, then this is 5 into DC. So what should be DC? Duty cycle should be 50%, that is 0.5. So 0.5 into 5 is 2.5. 2.5. So in Arduino, the digital output, sorry, the analog output that you're getting is not a constant. So if you're just, because what do we actually mean by a voltage of 1 volt and 1.2 volts or 2.5 volts? So if this is time, if it is 1.2 volt, then this is a DC 1.2 volt. If you want to have 2.5 volts, then this is DC 2.5 volt. Now this is not the type of waveform that you get in Arduino. So you will not be getting a constant voltage which is of desired value. If you can see here, I am not getting a constant voltage of, now it is, if I just press it, now you can see these voltages will change. When I release it is this much. Now is it like exactly 1 volt? So this is not a 1 volt line you are getting, but you are having effective average voltage is 1 volt. When I just press it, you're not getting a 2.5 volt constant, but you're getting a 2.5 volt average voltage. So if you just go back here, in order to get 2.5 volt, I have to generate a square wave of duty cycle 50%. If I want to get 1.2 volt, if I want to get 1.2 volt, I have to generate a square wave. I have to generate a square wave of what duty cycle? So what should be duty cycle of this? That I can calculate. 1.2 is required is equal to, from 5 volt, what should be DC? Then duty cycles, this is duty cycle. So this is not a DC, okay. Duty cycle. So this is duty. You should not get confused with that DC voltage. So duty cycle is 1.2 by 1.2 divided by 5. Can you see it is 24% duty cycle? So if you want to get 1.2 volts, so what should be the value that you should be feeding for getting 1.28? Sorry, 1.2 volt. For 1.2, it is 1.2 into 5 by 256. That is 1.2 into 5, or it is 0.2 into, sorry, this should be for getting how much you had it here. This is the requirement. So this is value that is required. If I want to get 1.2 volt, then it is 5 by 2 by 8 into x value. I should find the value of x. So what is x now? Is it not 1.2 into 256 divided by 5? Is it not 64? It is now, what you do is 1.2 into 256 by 5. So this is the decimal equivalent of 1.2 volt. So it is 61.4. You cannot give 61.4, give it as 61 or 62. So let me go back here and make this as 62. I'll make it as 62. Let me stop this and make it 62. Okay, I'll be displaying this as 62. If I'm not opening, I'll be getting 1.2 volts. Let me run this. Can you see, are you not getting 1.2? Can you see, are you not getting 1.2? This duty cycle is 24%. This duty cycle is 24. This is 1.2. When I press it, it will be 2.5. It will be 2.5. So likewise, we can able to do this digital read and analog out. You are reading a digital input. See here, if it is high, you are assigning V1 as 0, V2 as 128, which actually corresponds to an analog voltage of 2.5 volts. 2. Okay, let me stop this, and this actually corresponds to what? this actually 128 corresponds to, in this case, V2. V2 is of 2.5 volts. Here 62 corresponds to 1.2 volts. So likewise you can able to do this code. Thank you.